So we think about two major divisions of sampling. We mentioned one of the techniques of reducing sampling error would be to do what? Right, to do probability sampling. Well, the other type of sampling is non-probability sampling. And this is typically used in qualitative studies, right? When you're trying to understand more about a particular individual or group of individuals. Whereas we have the probability sampling. This tends to be used more in quantitative studies, in rigorous, high-quality quantitative studies. Right? Good research, good science should have and utilize probability sampling. Typically don't use this sort of sampling when we use qualitative studies, again, because in qualitative studies, we really try to understand more about an individual or a group of people, and so in that case, we want to do more purposive sampling, which is a type of non-probability sampling. And so in probability sampling, the goal is that our sample is representative of the population of interest, that they look relatively the same. At the same time, every single member of the population of interest must have a known and a non-zero or an equal probability or chance of being selected into your study. Hence, a random selection. So every single person in your population has an equal chance of being selected, and we know what that probability is in terms of a number. And so our first example of a probability sampling technique is simple random sample, also known as SRS. So you must start with a sampling frame, right? Think of a list, right? You must have a sampling frame. If you don't have a sampling frame, there's no way that you can do simple random sampling. Because this framing, this sampling frame, right, this list has the information, either names of every single person in your population. And so what we would then do is we give each sampling unit in the sampling frame a number. For example, an ID number. Okay, Jane Doe, you're going to be 001, and every single person after you alphabetically, we'll just number numerically. And so we just number them and assign each person a number. Then we decide the sample size that we need. Let's say we need a small sample, a sample size of 10 people. So then what we can do is we can do a few things in order for us to then figure out who is going to be part of our sample, which is 10 people. Well, let's say we had 100 people in our sampling frame and we only wanted to get 10% of them, so 10 people. Well, we know that there's an equal chance for those 100 individuals to be selected, but we only want 10 of them. So we have different techniques that we can use to figure out who is going to randomly be selected to be part of our 10 individuals in our sample. So we can have a computer randomly select individuals from a number, right? We can say our numbers are ranged from 001 to 100. And the computer will just randomly select 10 numbers. There you go. Any person who is identified as 003, 007, and so on and so forth will then be selected to be in our sample. Or you can use a table of random numbers to do the same thing. And you can go online and just pull any table of random numbers. And from here you can say, okay, let's just go either down the row and pick the first 10 numbers, or we can use the top row and go across and use the first 10 numbers, or we can use the first block and look at the first block and look at the top 10, the first 10. So right, in this case, we're looking at the top 2 rows of the first box. Right, so these random table of numbers we can utilize as a tool to help us. Okay, if you're this number, you're part of our sample now. Another technique is just like doing bingo. Right? We can put numbers from 1 to 100 in a bowl, in a hat, in a bingo tumbler, and draw 10 numbers. Right? The 10 numbers selected are the 10 people that will be recruited into your sample. And because we knew that there were 100 people, and we knew we wanted 10 people from those 100, we knew the known probability, and we knew that every single person had an equal chance of being selected to be part of that study. Hence, a simple random sample. And hence, an example of a probability sampling technique. We then have systematic sampling. Systematic sampling starts with a sampling frame, right? At least we know the number of people within our sampling frame. But you need to know how many people were in the venue from which you were recruiting, right? So you either have a list of student emails, you have a phone book, or you have a conference room full of 100 individuals. But you knew how many people came into your room, or you have in your sampling frame. Then we're going to divide the sampling frame by the needed sample size to find the sampling interval. Right? So if we knew we had 100 individuals and we needed a sample size of 10, we would divide 100 by 10 to give us our sampling interval, which in this case is denoted as K. So what this means is that for every 10th person to come in, or that we pick, that person is going to be in our sample. So we randomly select the starting point from among our assigned numbers from 1 to 100, or 10, and then we assign a value, right? So let's say it's 007. So now the person assigned 007 is in our study sample. So then, from that point on, every 10th person from 007 is going to be in our sample. So then we started with 007, so we add 10 people, so the next person will be 17. The next person from there will be 27. Next person would be 37. So every single person that came in to our room or that is listed on our sampling frame would then be included in our sample until we have a sample size of 10. Right, so we're using a system. In this case, the system is every 10th person. And that 10th person was determined by calculating the sampling interval. Then we have stratified random sample. We use stratified random sample when we want to make sure that certain groups will be included in the study. And this goes back to the idea that we might have a particular race or ethnic group that might be underrepresented or overrepresented in a population. So we want to ensure that we have an equal group of people within our sample. So we have our sampling frame. Right, we divide this sampling frame into subgroups called strata, right? Hence stratified random sample. So for example, we have our strata based on different ethnic groups: African American, white, Native American, Asian American, Pacific Islander, and then Latinos. And based on these different strata, we then simple random sample within each of these strata to then create our sample. So in that case, we now know that every single group would be representative within our sample. Right? So for example, Asian American Pacific Islanders, African Americans in places like Arizona, where these groups comprise of less than 2% of the population. So imagine if you were doing a study, maybe smoking behaviors among people who live in Arizona, or particularly who live in Flagstaff, Arizona. If you just did a simple random sample, the likelihood of you capturing Asian Americans or Pacific Islanders or African Americans within your sample is going to be very, very low. So when you have your sample of 100 folks, you're not going to have any Asian Americans or no blacks in there, and now your sample may not be truly representative of the population of Flagstaff, Arizona. And if it's not truly representative, then you have limited generalizability. Your results are only going to be related to people who are going to look like your sample. And if most of your population in Flagstaff, Arizona are going to look a certain way and your sample doesn't, then your research is limited. Right? So we can use stratified random sampling in order for us to capture some of these folks that might be underrepresented within a given population. And then our last probability sampling technique is cluster sampling, also known as area sampling. And this is when you have no sampling frame. Right? We don't have a list of attendees. We don't have a list of student names or rosters. Right? We don't have a sampling frame or a list of individuals from which we can draw a simple random sampling. So instead, what we do is we create a sampling frame in which the population is broken up into groups or clusters. And then those clusters we can then select randomly. So what we end up doing, right? So we could take, for example, we're looking at Uganda. And so if we're looking at Uganda, Uganda does not have a system in place where they have a census. So they do not measure who lives in Uganda. There is no infrastructure for that. So because there is no sampling frame, which would be a government census, we can take a look at the country of Uganda and take a look at the different villages within that country. And we can then say, okay, we have our villages within the country. That's our sampling unit. We can then take a look at within the within these villages and randomly select among these sampling villages different households, right? And even then, those households are still a sampling unit because we're still trying to figure out who are we going to actually interview. And in this case, it's going to be the individual people, right? The children, the mothers, the fathers, right? The people who live in these homes, in these villages within the country of Uganda, right? So the individual people are the observation units that we sample, right? The group of people that we end up sampling, getting information from would be our sample in itself, but a sampling unit were the households that were randomly selected from the sampling units of the villages that were randomly selected within the country of Uganda. So the last stage could be randomly selected in terms of the individuals, or we can say, you know what, we're just going to pick you, you, and you, and actually you have a daughter, so I want to actually have her fill out the information too. Right, so when it gets down to the very last stage of selecting your observation units, that could be random or it could not be random. But everything to that point, from identifying your sampling unit from the villages all the way down to your observation unit, there is some sampling, there is some randomness going on there in terms of randomizing your sampling unit. And so for your project, you guys are going to be doing a type of non-probability sampling called convenience sample. Right? This is essentially selecting whomever is available to you and is willing to be studied. The advantages of doing this type of non-probability sampling is that it's obviously quicker, it's cheaper, it's easier, and usually tends to be a more feasible option when it comes to time. Right? Convenience sampling, who do you have access to? So for example, for your project, you have access to yourselves, you have access to other classmates and other people who might be students here at Cal State Fullerton or beyond, right? So you can use yourself and you can use your colleagues and your friends who are college students, however you want to define who your sample is going to look like in terms of generalizing that to your population of interest. I will say that your population of interest should be college students, whether you want to limit that to Cal State Fullerton or to the region like Orange County or even broader to Southern California. You should define who your population of interest is. I am just setting the parameters that your population of interest at a minimum should be college students over the age of 18 years old, right? So you shouldn't be sampling anyone under the age of 18, and you shouldn't be sampling anybody who is not a college student.